welcome to my EDU5PMN Assessment Task 1 presentation. My name is Emma Jamison and I hope that you enjoy and get something out of my presentation. My conceptual foci that I've chosen are the use of pictographs and bar graphs for children at levels 1 and 2. Young children are naturally curious and intuitive when it comes to mathematics. They frequently have burning questions in their minds that they will often voice and need the answers to. Children at levels 1 and 2 are generally learning the basic foundations of mathematics and mathematical language, essential for the development of maths learning. Students at this level can access powerful mathematical ideas relevant to their current lives by developing an awareness of the collection, presentation, and variation of data, and a capacity to make predictions about future or chance events, either hypothetical or real world. These foundations facilitate the importance of children posing basic mathematical questions about their world, to identify and investigate possible strategies and solutions while solving problems meaningful to them. Understanding and experiencing these concepts in the early levels provides a foundation for future progression in mathematics, following the course to algebraic, statistical, and numerical thinking. Bar graphs and pictographs present as a means of communicating and interpreting data. Each graph has its own way of presenting information that benefits one set of data and the way of interpreting information over the other. Bar graphs. A bar or column graph can be a horizontal or vertical graph that has values on one axis and labels on the other axis. The data is presented on the graphs by using a column or rectangle-shaped object. The advantage of using a bar graph is the ability to compare and contrast variances between one or many sets of data quite easily. Children can use different colours to compare and contrast two sets of data. The graph should always include a title and labels on each axis to provide context for the user. The difference between a horizontal and vertical bar graph is that a vertical bar graph will have the values on the vertical axis and the labels on the horizontal axis, where the horizontal graph will include labels on the vertical axis and the values on the horizontal axis. Pictographs. Again, as with bar graphs, pictographs employ the use of labels, axes, and titles to give the user context of what they are looking at. Pictographs represent the data in picture form, showing how many is in each category individually. This graph is relatively easy for children to construct and understand. It can be done with glue and a large sheet of paper. The axes can be labelled either way, makes it a bit easier and stress-free for the classroom. The 21st century child. Graphs are also a means of children becoming familiar with data handling and understanding statistical inferences. Through their media and technology devices, the 21st century child will encounter large amounts of data on a daily basis. A lot of this information will be conveyed through the use of statistics and graphs, and knowing how to deal with these data is a skill that children will require in modern society. The ability to interpret and critically evaluate data is known as statistical literacy and is as necessary for efficient citizenship as the ability to read and write. Broadly speaking, data handling and statistical numeracy is about young children gaining an understanding of chance. Chance involves the understanding of randomness, the certainty, possibility, and impossibility of an event, and how likely particular events occur, aka, will it rain tomorrow? Teachers can access children's interest with data and statistics by using information or events from the real-world context for their students to investigate, as applying and interpreting statistics in the real world is a key skill for all people in the data-rich 21st century. This skill can be described as statistical numeracy, literacy. Children experience these variations of events in day-to-day life, and these form the start of basic conversations of statistics. These basic conversations are used as a basis for finding meaning through the use of statistics and data collection. Bar graphs and pictographs fall into the statistics and probability strand of mathematics learning. When students are learning statistics and probability, they are partaking in meaningful collection and investigation of data and are learning to recognise their ability to analyse and draw inferences from that data. Statistics is about numbers in context. Students develop an increasing ability to critically evaluate chance and data concepts and make reasoned judgments and decisions, as well as building skills to critically evaluate statistical information and develop intuitions about data. Pictograms are used as an introduction to data handling and representation. Data handling uses many aspects of mathematical thinking. It's about collecting, sorting, representing, analysing, and interpreting information. In order for Level 1 and 2 students to engage successfully in statistics and probability learning, prior conceptual understandings must first be achieved. At the foundations level, students' ability to interpret data would first require some numerical knowledge, such as one-to-one correspondence, which is important for understanding the meaning of the data. Students begin investigating simple data to determine true or false statements. Students answer yes or no questions to collect information. They determine the best way to consolidate the data using hands-on equipment. Students will organise answers to yes or no questions into simple data displays using objects and drawings, and then interpret simple data displays about yes or no questions, encouraging the learners to become familiar with unpredictability or chance in some events. Presenting children with data depicted in a pictograph provides children with the chance to pose questions and discuss the possibilities of the data with their peers, engaging children significantly with math concepts. At every level, it is likely that students will be able to read graphs of a given type before they can construct them, whether with assistance or independently. Moving forward, once the students have achieved their foundation understanding of data, sorry, I'd pressed the wrong button. No, I did press the wrong button. Thank you. The Level 1 student has the capacity to read and interpret a larger amount of data. Generally, when the student has become confident with numerical information or one-to-one correspondence with pictograph objects, they will have the ability to recognise the number of items in each category by the length of the column. This directly links to the Victorian curriculum, where the Level 1 student is expected to represent data with objects and drawings, where one object or drawing represents one data value. And they can describe the displays also. Obtaining and representing real-world data with children can provide multiple opportunities to reveal aspects of children's own lives and communities, highlighting the significance of mathematics as a tool for describing, comparing, predicting, and decision-making. Children at the Level 1 stage of learning are capable of being able to identify outcomes of familiar events involving chance and describe them using everyday language such as will happen, won't happen, or might happen. Investigation experiences that are linked to the real world and to children's current interests will have more meaning. When given the opportunity to investigate a topic meaningful to them, Level 1 students will be able to choose simple questions and gather responses with a sense of purpose. Similarly to the Level 1 student, Level 2 students will also pose and solve problems that are related to chance. While a Level 1 student will justify that some events are certain or impossible, the Level 2 student will delve deeper into this context by identifying practical activities and everyday events that involve chance. This will be achieved when classification of a list of everyday events is attained using the language of chance. Demonstrated when the individual can describe outcomes as likely or unlikely and identify some events as certain or impossible. As with all levels of students, those who partake in investigative experiences that are linked to the real world and to children's current interests will have a defined context of what they are learning. This relates to the curriculum when Level 2 students identify a question of interest based on one categorical variable and follow it through purposefully, investigating to gather data relevant to the question. At this stage, students should be introduced to and recognise the use of telemarks when out collecting data. They will begin to distinguish objects, identifying categories in order to collect, check and classify data. Once the data has been collected, students will identify the best way to display the information by comparing the usefulness of each graph and the purpose needed for their interpretations. Students will create displays of data using lists, tables, and picture graphs and interpret them. For example, a student may use a bar graph over a picture graph as a means of comparing two sets of data and make decisions based on the data results. Proficiencies. Bar graphs and pictographs are categorised in the Victorian curriculum mathematics proficiencies. The collection and classification of data and analysis of graphs falls under the problem-solving and reasoning categories. Reasoning refers to students developing an increasingly sophisticated capacity for logical, statistical, and probabilistic thinking and actions. Problem-solving is the process of developing deep understandings and applying ideas to real-world situations. It motivates students and shows them practical reasons for learning. Statistical thinking uses children's ability to problem-solve and knowledge of numbers. When children are exploring data, they are counting, measuring, classifying, calculating, and estimating, summarizing, comparing, and making connections with the real world. This is where data handling is important, as all students need to be provided with opportunities to participate in collecting and handling raw statistics, packaging it for presentation to others, and practicing interpreting and making inferences from this data. Thanks, Booker. It is essential that students understand how to construct and interpret graphs, but also how to make meaning from the graphs, understanding what each graph makes visible and which graph is most appropriate for a given situation. There are three approaches one can employ, termed graph sense by Friel, that helps to determine where the students' understanding and interpreting of graphs lie. Number one is reading the data. Students should be able to determine an answer to literal questions about the specific data pictured in a graph. Reading the data requires that students understand what a graph is, what the axes present, and where the data are located, and what they represent. Reading between the data. Number two, students can identify and explain relationships in the data portrayed in the graph. This requires that students understand not only the basic structure of the graph, but also make sense of variation in values or types of data portrayed. Number three, reading beyond the data. Students can extrapolate from the data the relationships contained therein, but also the context in which the data are presented, using the graph to answer questions that extend beyond the data contained in the graph. As I said before, children are naturally intuitive and curious about math. However, when it comes to collecting data, children can find this tricky. As children begin to collect the data, and they are always so excited about it, the idea, for example, of who is the same age as them, they can forget who exactly they have asked and who they haven't asked, resulting in information that is inaccurate. Cook 2008 advocates for the use of open class discussion about the best way to keep track of this and suggests the use of class lists. Children can often have difficulty distinguishing between the data and the larger event from which the data was collected. They can think of the data as triggers or pointers to the event, not as abstracting information about the event. For example, instead of recognizing more children have dogs than cats, the children might discuss what they feed their dog at night time. Focusing on the meanings of symbols used in graphical representations will help. Having children interact with graphs is not as much so they learn the technique of graphing, more so the way data represents information. Initially, when asked to interpret results, children may focus on individual pieces of information instead of the data as a whole. A child in Level 1 may answer a problem based on the position, colour, or personal preference, as there is no prior connections between expectation and variation. Level 2 children have little notion of variation and when looking at two sets of data, they might see one has more as they visually compare the two graphs. Focusing children on the shape of the data or how they are alike and how they are different may help. If children forget to label their work correctly, they will not have a context for which to relate their findings to. Correct labeling of the values and categories and giving the graphs titles will keep children on track with what they are discovering. There are some common mistakes that students make when forming bar graphs. These kinds of mistakes prove confusing or deceptive to the students who are reading the data. These mistakes or difficulties can present as unequal widths of columns or bars, inconsistent or no spacing between columns and bars, because if the bars touch then the graphs start to look like a histogram, and poor choice of scale, making it difficult to interpret the data. There are also some common mistakes that students make when forming pictographs. These kinds of mistakes can become misleading to the students who are reading the data. These mistakes or difficulties can present as pictures that are of inconsistent sizes, misleading the students for the amount of data it represents, similar to if the gap between the pictures are not uniform in size and the gaps are larger between the pictures. Children may simply look at the graph visually and assume the taller line has the most amount of data. Clear lines and consistent sized pictures will help avoid this problem. Investigating experiences that are linked to the real world and to children's current interests will have more meaning and purpose. Before children can collect data, they need to learn to identify attributes and pose questions about the world. Begin with concrete experiences using the children themselves. Children's thinking is developed through active involvement, not only in activities and set tasks, but also through discussion and questioning. Children should construct graphs by hand and with technology. The intent is to get children involved in accurately communicating a message about their data. In my research, I've discovered a few ways to use technology within the classroom to help students gain a deep understanding of graphs. There are several websites that have many various graphing games or varying levels and degrees of complexity that children could explore in the classroom. Use of an interactive whiteboard for whole class discussions will be a useful asset. There is an interactive maths game website called Cambridge Hot Maths that can be played on the interactive whiteboard and enhances mathematical content and knowledge. Graphing can also be done on Excel and displayed on the whiteboard also. As a whole class, decide on what question you want to answer today. For example, favourite pets. Have a discussion about what kinds of pets to include, and maybe choose an animal that may get a 0 as a point of debate about the number 0. Open the column graphs widget and type the chosen question into the title and put the values and labels on the axes. Make it clear that you are only allowed to vote once. Start the vote and give children who haven't voted jobs, so they are involved in the graphing process of either counting or recording of the data. Allowing the children to suggest their own question is another way of getting children involved. Collecting data. Teachers should model suitable questions and support children in posing questions and data. Discussing the strategies for collecting data that can be generated by counting or measuring things and asking groups of people or watching what happens. For a further investigation and understanding of what the data represents, there is a widget that focuses on using tally marks and data collection. Data collected could also be summarised on an Excel spreadsheet. Using this hot maths as an teaching activity will help counteract a common misconception and conceptual difficulty that is children can often have trouble distinguishing between the data and the larger event from which the data was collected. Increasing attention to observing the number of items in each category, active engagement of different types of graphs over multiple medias, and focusing on the meanings of symbols used in graphical representations will help and while appreciating using tokens of uniform size. A few links for you, and if you bear with me, I'll just quickly So this is the Hot Maths, one of the graphing games that you can do. Quite easy to drag and move around however many numbers you want. It can be vertical, it can be horizontal. You could also count in 2s, or you could count in 10s, whatever's up to you. This is how you change the labels. Easy. And I just quickly wanted to show you the Hot Maths website, so you can go on there and you can do lots of different things with the children. You can do surveys, you can do tally tables, work with pictograms, graphs work with more columns, comparing graphs. So there's lots of information on there you can do with the kids. Also, if you wanted the children to work on a computer or an iPad by themselves, lots of interactive games on here, lots of fun things they can do. This is a snail race, so they get really competitive. This is actually really good. Goes from tallies to, sorry, slow internet today, so it goes from tallies to bar graphs to pictographs, so it's got lots of different things that you can use. Also, where is it? Here. This is for children to create their own graphs, so lots of hands-on, lots of interactive things. They can choose what graph to do. Lots of they can have lots of different information they can put in, and then of course this is a pictograph site. Really easy to use, and a lot of repetition, and they can change the words, they can do whatever they like. So, just a few interesting things that you can use in your teaching to work with bar graphs. And so there you have it. I hope you enjoyed that. And thanks for watching, and I guess I will see you around. Thank you. Bye.